Hey everyone, welcome to Rocks for Jocks. Recently I've gotten a number of questions from friends and family over the 4.8 magnitude earthquake in Tewksbury, New Jersey on April 5th, 2024. In the scale of all earthquake events, I think it's important to recognize two things being true at once here. First of all, 4.8 magnitude earthquake is not that large. Barely any damage is going to be caused by this event, even when it's occurring near multiple major cities. From what I saw online, there were some reports of people saying plates fell out of cabinets. Small things like that were broken, but as far as I've read, nobody's homes were destroyed. Nobody got severely injured from the earthquake itself, nothing like that. At the same time, the second thing we can acknowledge is that a magnitude 4.8 earthquake on the US East Coast is pretty rare. In my mind, that alone is worth acknowledging, learning more about it, discussing about how to better prepare for future events, etc. News and social media have already acknowledged this event for everyone, so I think we can move on to learning more about this event and ones like it in the future. A lot of people know that earthquakes are associated with the terms tectonic plates and fault lines. So what are these tectonic plates and fault lines? Do we have any of them in New England or on the East Coast at all? Well, the answer is it's a little complicated. Tectonic plates cover our whole planet. They make up our crust of the Earth. And I have a whole separate podcast on tectonic plates alone. Fault lines typically occur on the border between two tectonic plates, thinking of the San Andreas fault line, for example. And statistically speaking, earthquakes occur much more frequently and they're much stronger near fault lines compared with the middle of tectonic plates. So that's why people are oftentimes going to talk about which tectonic plate we're on, which tectonic plates we're near, which fault lines we're near, anything like that whenever earthquakes occur. So I just mentioned that earthquakes occur more frequently and usually stronger near fault lines. But as we just saw here with the New Jersey event, events do sometimes happen in the middle of plates. These events are going to be a little more rare and are known as intraplate events. These intraplate events are also sometimes referred to as background seismicity. They are usually located at fault lines that tried to form in ancient times and didn't really form all the way, or partial plate fractures, so like a fault line that doesn't necessarily connect to any others. But overall, intraplate events in background seismicity events. They're not very well understood, so sometimes there is going to be some disagreement over exactly what causes different intraplate events. Regardless of where the events are located, I think it's pretty interesting to look at the relationship between frequency and magnitude of events. The way I like to think about this relationship is that at any given location, we can think of a curve on a chart where we have magnitude on the x-axis and frequency on the y-axis. The line representing the relationship between the two variables starts in the top left corner with high frequency of low magnitude events, which means we have a lot of events that are in the magnitude 2, 3, 4, 5 range. And then the line representing the relationship kind of curves down with increasing magnitude until we get to a low frequency of high magnitude events in the bottom right hand corner of that chart. So that means that when we get to events of magnitude 8, 9, and 10, those are going to occur with much less frequency than the lower magnitude events. And that relationship typically holds true regardless of what area we're looking at. However, the location of the curve on that plot changes. What I mean by that is if we're looking at a higher seismicity zone, so if we're looking at earthquakes in San Francisco, for example, the line on that plot is going to be higher, which means the frequency of events of any magnitude is going to be higher. On the other hand, if we're looking at a lower seismicity zone, so if we're looking at New England, the line on that plot is going to be lower, which means we have a lower frequency of all events of all magnitudes. So that relationship is going to be why we occasionally get 4.8 magnitude event on the East Coast, but it's going to be much rarer than that same level of event on the West Coast in Seattle or San Francisco, for example. If we follow that relationship all the way to the extremes, we can think we get two kind of interesting inferences from this. We can recognize that low magnitude events, even in New England, happen pretty frequently. I used to work at the Western Observatory, where we tracked earthquake locations in magnitudes and durations and posted them online. And we were able to see on our seismometers several events per week and display that information to the public. On the other end of the extreme, that also means that higher magnitude events do occasionally happen in New England. The last large super damaging event was a couple hundred years ago. But yeah, not something you need to worry about on a day-to-day basis. Okay, taking a step back, a minute ago I said that we occasionally get 4.8 magnitude events on the East Coast, but they are rarer than ones on the West Coast. One interesting caveat to this as well is that New England and other similar low seismicity places don't necessarily build up structures to stand up to large events as much as cities on the West Coast. So there are going to be cases where low and moderate strength events on the East Coast cause damage simply because our building vulnerability might be slightly higher than similarly built structures on the West Coast. The next question I have from someone is, what is magnitude? So magnitude can be measured in a few different ways. Moment magnitude is the version that almost all modern researchers used, while two other scales are also pretty well known. The other two that you may have heard of are Richter scale and the modified Mercalli intensity scale. The modified Mercalli intensity scale measures damage to structures, so usually buildings, but that can also be gas pipelines or plates falling off a shelf, human reactions, if someone fell out of their bed, for example, anything like that. This scale is really helpful to track historical events using written descriptions. The biggest drawback to the modified Mercalli intensity scale is that it varies heavily based on how far you are from events or if the soil underneath where you're located amplifies the earthquake shaking waves, for example. It also has a pretty big drawback of involving a lot of human bias. So if someone claims that a plate fell off of their shelf, whereas maybe they just never put the plate on the shelf to begin with, or if they claim that a crack occurred in their chimney where the crack was already in the chimney, things like that start coming into play. The second type of scale that is very commonly reported on is called the Richter scale. This was popularized in 1935 by Charles Richter. This scale uses seismograph traces, which are going to be instruments that record the ground shaking caused by an earthquake, along with distance to an event's epicenter to assign a number to that event. The scale uses the size of the wave and the duration of the waves caused by an earthquake to create that number. This scale worked really well in California, where most earthquakes occur within the top 16 kilometers of the crust, but corrections were needed for events that occurred deeper down. The magnitude scale, announced now on most official channels and used by most researchers, is called the moment magnitude. This is essentially going to be the amount of energy released by an event. It provides a really clear way to compare strengths of events which occur all over the world, whether humans or sensors are far away or close by, whether we feel them or not. Essentially, we use the physical properties of the event to create this scale. So we take the area of the fault which has slipped, which is going to be the width times its height, and then multiply that by the distance it has slipped. That gives us a, quote, volume of slip, unquote. Then we plug that volume into a formula along with the strength of material, which is going to be how much the soil or rock in that area resists slipping. And that formula gives us a number from 1 to 10, which then becomes widely reported in the news, sometimes along with the Richter scale or even occasionally modified Mercalli intensity scale. The final topic I want to touch on briefly today is about whether climate change affects earthquakes. Short answer, no. Climate change plays a part in almost all natural disasters, but does not directly affect earthquakes. In my other Tectonics episode, I discussed in a little bit more depth how earthquakes are formed. So here, I'm just going to say briefly, they are caused due to the motion of tectonic plates moving across the earth, which are not directly affected by the climate. With that said, I sat around and thinking about this for a couple minutes, and I have to throw the caveat in here that maybe there is a possibility that a huge swing in temperature or humidity would slightly speed up or slow down tectonic plate movement. But that would be such a huge change in the climate that we'd have much bigger problems in our hands than the tiny difference in number of earthquakes per year. We'd have way more hurricanes or heat waves and cold fronts and all of that to worry about. One more point to make here is that while climate change does not affect earthquakes, researchers have found cases where fracking for oil increases the magnitude and frequency of earthquakes in particular areas where fracking is really common. So in other words, earthquakes are not influenced by climate change, but definitely influenced by other human events. As far as what I've read, almost all of those studies linking fracking and earthquakes have been in Oklahoma or Texas. So I would not link fracking to New Jersey event unless some other strong evidence comes forward. A quick Google search that I did tells me there's no fracking in New Jersey. It was banned in 2012 to 2013. Now, New Jersey is a pretty small state, so I was wondering if maybe fracking nearby could have been causing this. So they're in the states nearest New Jersey. Fracking was also banned in Delaware and New York in 2021, but there is a lot of fracking in Pennsylvania, which is also bordering New Jersey. In other words, I guess fracking is a possibility for the cause of this event, but I would not necessarily push that as a leading theory unless any other super strong evidence comes forward. Thank you all for listening. I hope you enjoyed this episode and learned something fun. Take care.